Hello friends, welcome to Science Talk. I am your host Jim Massa. I want to discuss with you a story involving microbes and how the microbes have an important role in dealing with the climate situation. And this is a report that was published in the journal Nature Reviews Microbiology. And basically, 30 scientists from about 9 different nations have basically provided the following admonishment. Don't forget the microbes. They argue that research is ignoring microbes and that life forms that add up to a huge proportion of living matter on a planet are being largely left out of climate calculations. When you consider the biomass of the prokaryotic organisms, which include microbes and bacteria, etc., the biomass from prokaryotes is more than all the biomass from eukaryotic organisms. Eukaryotic organisms are multicellular organisms or protistans that have a defined nucleus region in their cell that is surrounded by a nuclear membrane. So, yeah, these organisms need to be factored in and considered when looking at the climate issue. The problem is they're so small they're hard to see. So what about them? Microbes have been around, almost 4 billion years. Right? The planet's 4.5 billion years old or so. 3.8 billion years is what we have evidence for microbes being around since. And they use the sunlight energy. They take whatever chemicals are around and they generate food and grow tissues and so forth. The mass of all the microbes on the planet probably contains 70 billion, with a B, tons of carbon alone. And they are basically biodiversity's bottom line. Right? They were the first, they'll probably be the last living organisms on this planet. They are the only living organisms at vast depths and colossal pressures. There's evidence of microbes existing in the mantle of the planet. Many survive at temperatures beyond boiling point, in lakes composed of alkali, or in lakes that have very low pH, which are acidic lakes. They can even digest radioactive material. Yeehaw. They can survive in just about any type of environment that would kill you or I. They can survive in many harsh environments. They affect the chemistry of the atmosphere. They colonize the intestines of ruminants, colonize your intestines. And of course, we know that ruminants, fart, burp out methane. They bury carbon at depth. They decompose vegetation to release new atmospheric CO2 and methane, for example, when the permafrost thaws. They support all life and powerfully affect life's health. They affect climate change and in turn are affected by climate change. So Riccardo Caviccioli of the University of New South Wales in Sydney, Australia states, microorganisms, which include bacteria and viruses, are life forms that you don't see on conservation websites. He continues, they support the existence of all higher life forms and are critically important in regulating climate change. However, they are rarely the focus of climate change studies and policy developments. Professor Caviccioli and his colleagues from Germany, the US, Norway, UK, Switzerland, Italy, Netherlands, and Canada issue what they call their consensus statement. And that, of course, as I mentioned earlier, has been published in the journal Nature Reviews Microbiology. Now, to be fair, not that climate researchers have not been aware of microbes, but there's plenty of evidence of the role that they play in ocean warming and on land. But the consensus statement says it documents the central role and global importance of microorganisms in climate change biology. It also puts humanity on notice that the impact of climate change will depend heavily on the responses of microorganisms, which are essential for achieving an environmentally sustainable future. So what are they recommending? They want to see more research. They want to see closer attention to the microbial role and underpinning of climate change. They want more education on them. They point out that 90% of the mass of living things in the ocean is microbial. Marine phytoplankton take light energy, right, from the sun, right? They photosynthesize, and they take out CO2 from the atmosphere, right? They're the primary producers. Phytoplankton, zooplankton, so on. A warming world could mean a diminished ocean food web. Right? Now, there's some physics involved with that, and I'm preparing a report where I discuss how the upper 300 meters of the oceans have warmed considerably, and that can lead to a permanent seasonal pycnocline, which then, if you don't get the mixing in the upper layers, there won't be nutrients for the phytoplankton to carry out their primary producing roles. Food webs, food chains will collapse. On land, microbes are powerful agencies in both agriculture and disease. Right? We already know about what ruminants do when they ruminate and they release methane. So decisions about global farming practices also need to consider these consequences, says Professor Caviccioli. And lastly, climate change worsens the impact of pathogenic microbes on animals, including humans, because climate change is stressing native life, making it easier for pathogens to cause disease. So the bottom line is, not enough attention is being given to microbes and their role. And this report is basically saying that needs to change. We need to examine their role more carefully and ascertain exactly their contributions to matters and include what they do in the modeling. Something to think about. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.